Welcome to the platform of learning and sharing. In this video, we will be studying about material balance, also known as mass balance. Okay. At first, we understand the basic concept of material balance, and then we will be applying material balance on a single unit system. Okay, and we will solve this particular problem in this video. Okay, if you had not subscribed my channel, please subscribe it without delaying further, and this will give us confidence to make such educational videos for you. Okay, here it is a problem which we will be solving. Okay, at first just look into the diagram, or the flow where one inlet and four out streams. Okay, at first we understand the material balance concept, what the actually material balance is. Okay, material balance or mass balance is that anything which coming in the system will go out with same quantity or things. Okay, uh, material balance equation shown here right, that input equals to output. Okay, we consider this equation for steady state operating conditions where pressure temperature are constant. Okay, so another equation for material balance is that for non-steady where temperature and pressure are variables and change, so we have equation of material balance in that particular situation is accumulation equals input minus output. Okay, for non-steady state. Okay, but in this video we will be solving a problem of steady state. So uh, I want to uh, tell you that for steady state where temperature pressures are constant and not changing, so we consider input equals to output. We just equate the inlets, the streams of inlets and the output streams, and apply balance accordingly. Okay, input equals to output for steady state uh, condition. Okay, now in this particular problem we have one inlet going into the system is accumulate system is distillation column. Okay, uh, another equation for material balance which used for non-steady state, non-steady state or system known as where temperature and pressure are variables and change with time or any other respective variable. Okay, so for that particular case we will be using accumulation equals input minus output. Okay, but in this particular video we will be covering the above equation, the steady state process condition, because we will consider the temperature pressure constant because no information for temperature and pressure given in the problem which we will be solving here. Let's look into that problem. Here is no discussion or mentioned about anything on pressure or and temperature, so we will consider this a steady state process. Okay, what we do, we just use the material balance equation of steady state, supposing that it is a steady state condition system. Okay, now just look into the system. Then we will read the problem statement. At first, just look into the system where one inlet is coming from the left hand side. The overall mass flow rate given as 1000 kg per hour on the left, with the mass fraction of benzene and toluene, okay, 0.5 kg benzene. B means benzene, T means toluene, okay. 0.5 benzene and toluene, okay. Just start reading your problem now. 100 kg of per hour of mixture of benzene and toluene. So in the problem we will be mentioning benzene as B, toluene as T, okay, containing 50% benzene, and by mass fraction is separated into two fraction, okay. The inlet have two uh, fractions, 0.5 benzene and 0.5 toluene, because there only two balance, only two fractions or only two uh, things are mentioned on problem, benzene and toluene, okay. So 50% is benzene, so another 50% will be toluene, okay. So 50% is written as 0.5 after dividing it by 100, and similarly the 50% of toluene is also written as 0.5 after dividing it to 100, okay. So 100,000 kg per hour is the overall or total input which is going into the system, and 0.5 is the mass fraction of benzene which is including in 1000, okay. The toluene part is also 0.5 in this 1000 kg per hour of inlet stream, okay. Now just read the question ahead. The mass flow rate of benzene is 450 kg per hour, and that of toluene is 425 kg per hour, okay. Now the benzene, which is also located mentioned on our diagram, 450 kg per hour, okay, on the top left of our diagram, okay. This 450 is benzene kg per hour, okay, and the 4 to 5 which is also mentioned on question for the toluene is mentioned in the diagram at the bottom left outlet stream of our problem, okay. 4 to 5 kg of toluene per hour, okay. Now what we have to do, we have to calculate the unknown flow rate of output. Unknown flow rate. Unknown flow rate are mentioned by variables, by alphabets in outlet streams, okay. Here we have two output uh, things which are mentioned by alphabets or variables, okay. On the above right hand side, top right, we have exiting empty kgt per hour. It is it will be the mass flow rate of toluene, okay. Now at the bottom we have mb kgb per hour. It means we will be solving on the bottom for benzene, okay, to find the benzene uh, mass flow rate at the bottom and the mass flow rate of toluene at the top of the system, okay. So what the question is, the unknown flow rate of output, okay. To two output flow rates are unknown. One is empty at the top right corner, and another is mb on at below Okay, so what we will be doing, we will be applying mass balance equation or material balance equation for our this system, for our this steady state system. Why steady state? Because no discussion and no information is given for the temperature and pressure. We considered it as a steady state process. Okay, if the temperature pressure was given, we con- considered it to solve a different way by using the accumulation equation for unsteady state. But as there is no information regarding temperature and pressure, we will be applying material balance for steady state by using input equals to output for our system distillation column. This one or single unit uh, system. Okay, we have one stream going in into the system and four streams going out. Okay, oh, there are two main outlets, one from is at top and another is at bottom. Okay, above we have also the benzene and toluene in the inlet. So similarly we will be having toluene and benzene in the outlet streams. So above benzene flow rate is given, we will find the toluene mass flow rate at top. Okay, for bottom case, for below case, we will be finding for the benzene mass flow rate, because the another or other flow rate of bottom for toluene is given as 4 to 5 kg toluene per hour. Okay, so we have two unknown flow rates. The question is asking to solve or calculate the unknown flow rates of output. So here in our system we have two outputs that are unknown. One is at top, the empty term, mass of toluene at top, and at bottom, MB, mass of benzene or mass flow rate of benzene at the lower exit stream. Okay, now we will be applying material balance in this equation. At first, we apply material balance for overall system, and then we will be considering for individual or the benzene material balance or the toluene material balance. Okay, now just see here what actually we will do. We equal input and output, as I mentioned, for the steady state case. Okay, here we have two cases, two compositions, or two I would say that benzene and toluene. Okay, for benzene balance, what I do, I will apply the benzene in equals the benzene out. How many, the amount which is entering in our system of benzene will equate the benzene which is out, going out from our system. Similarly for toluene, the toluene in and the equals to will be equal of toluene out. Okay, so we will be using these individual mass balance to calculate the unknown flow rates of our system. Okay, now let's write the benzene in thing. Okay, let's just look into the left hand side of your system. The fraction for benzene is 0.5 kgV per hour. Okay, so 0.5 will be multiplied with the total mass flow rate of the system, which is given as 1000. Okay, so 0.5 into 1000. 0.5 is the mass fraction of benzene which is going in. Okay, now equals to benzene out. Okay, there are two benzene out of from which are exiting from our system. One is at top 450 kg B per hour. B means benzene. Okay, so its value is given. Another benzene thing which is exiting our system is MB, which is located in the below section, below exit section, which is to be which values is to be calculated. Okay, now we multiply 0.5 into 1000, we get 500, and we will move the 450 on left hand side, it will become minus 450. As we have to estimate the MB, then the M 500 minus 450 means 50 kg B per hour. Okay, so the below section is solved now. The MB value is 50 kg per hour. What we did, we just applied mass balance on benzene. Okay, now to calculate MT, which is on top, we will apply the toluene balance, the toluene which is going in our system and the toluene which is going out from our system. Okay, similarly 0.5 kg T per hour, which is which we estimated from our problem statement, that 0.5 for toluene into 1000 for overall mass flow rate, which was given in the question, equals to, there are two toluene exits from our system. One is at top of the system, one is at below of the system. The top one is unknown, which is written as empty, plus the 4 to 5 which was given in the problem statement, also in the diagram below section. Okay, 0.5 into 1500 plus 4 to 5 become minus 4 to 5 in left hand side. We have to calculate empty value. Just subtract 4 to 5 from 500. What will we get? What will we get? If you estimated as 75, you are right. So the second unknown variable is also calculated now. Thank you for watching our video. Please follow for more such educational videos.